You have a problem that looks like this. Do you guys see it? We didn't do it yesterday. Okay, and let's do it today. Okay, now this only works if f and g are inverses. All right, so here it does say f and g are inverses. Is that in your notes? Do you see it? Yeah. Okay, so on the back of your notes. Okay, f and g are inverses. If you want the derivative of an inverse, okay, then it's just a formula. G prime equals, what do you guys write first? It's on the back of your notes. Okay, G prime equals 1 over f prime. Okay, this is your formula, all right? If you had f prime of something, let's say if this were 2, you'd say 1 over g prime. Okay, so that's the first thing you do. You just write your formula. This is your formula. This is only true if f and g are inverses. All right, and then what you do is you know that this is actually the x value of your g. Okay, in the parentheses, it's always the x value. So what that means is that this inside number here must be the x value of your what? F. Everybody good with that? Okay, so if this is the x value of your g, this must be the x value of f. Inside the parentheses, it's always the x value. All right, then you go onto the side of your paper and you do a little micrograph. Okay, I made that word up yesterday, so I'm going to use it as much as I can. All right, so what you're going to do is you're going to say, if this is the x value of my g, there are corresponding parts here if f and g are inverses. If this is the x value of my g, so it's some point, right? So it's 2 comma something. That means this up here must be something comma 2. That's just the rule for inverses. If this is 2 comma something, this must be something comma 2. All right, so the question is, can I find the x value of my f? It's like a puzzle. I need to figure out what this number is. Well, this number here is going to be the same as this number here. Okay, so if I know the y value of my f is 2, can I figure out what the x value of my f is? Okay, I've got this equation. All right, well, remember, f of x is just a code name for y. So this right here is the y value of my f, which is 2, is equal to x squared plus 1. Go ahead and solve this. If I subtract both sides by 1, I'll get 1 is equal to x squared. So therefore, x is equal to plus or minus 1. Okay, so that is the value of my x, which is this number right here. But there's a little bit of a caveat. I can't put 2 numbers in here. Okay, so which number is it? It's where x is greater than 0. So which one would I pick? Positive 1 or negative 1? Positive 1. So I'm going to say x is 1. So that means if my y value is 2, my x value is 1. If this is 1, 2, this is 2, 1. That's just how inverses go. And then what number goes right here? 1. It's the x value of your f, okay? And then I just plug into this formula and figure out what 1 over f prime 1 is, all right? Well, can I figure out what f prime is if I know what f is? Sure. F prime of x is equal to 2x. But I don't want f prime of x. I want f prime of 1. So this will be f prime of 1 is equal to 2 times 1. And what's 2 times 1? 2. Okay, be careful. My answer is not 2, though. The denominator is 2. So what's my full answer? 1 over 2, 1/2. All right, so that's how you do this problem. Let's do another one. So guys, every problem is very similar. Oops. Let's go to this little table problem, kind of, this one. Okay, can you guys make a correction, please, in your notes? This here, yours says 4, but it should be negative 4. So can you change this right here to negative 4? All right, okay, so they give you a whole bunch of things about f and f prime, and it says f and g are inverses. This is the key thing. If you know that f and g are inverses, then you write the formula. G prime equals what? 1 over f prime. Like, that's just how you start out. That's always your answer. If you could find this answer. Yes, yes. Only if they're inverses. Yes. Okay, so then what you do is you say, all right, inside the parentheses, I know that this parentheses is an x value. They're always x values. X value of which function, though? Of my g. Okay, so that means inside this parentheses must be the x value of my f. All right, go ahead on the side of your paper, put a little micrograph, okay? And these numbers always have to be like the switch of each other. I know the x value of my g, so the coordinate point would be 3 comma something. What does that mean about the coordinate numbers of my f? Something comma 3, nice. Okay, so this is 3 comma something, this is something comma 3. Now the question is, can I find my x value of my f? So come up to all these things that they give you. If I know my y value for my f is 3, could you tell me what my x value is for my f? 2. Do you guys see where we're reading that? Okay, so that means this is going to be 2, that means this is going to be 2, and that means this is going to be 2, because this is the x value of my f. Okay, and then you just figure out what this is, and that's the answer. What is f prime of 2? -4. So this answer is 1 over -4. Or you could say negative 1 over 4. Same thing. Okay, that was pretty nice. I think we're done with our notes. Is that right, guys? Can we go look at our homework? Let me go to the solutions for your homework. Huh? Oh, wait, no, we're going to go over our formula sheet too. I just realized there's one more question, I think, on your notes. Or did I do all of them? Yeah, I think there's one more. Okay, this one right here. This one right here, I think. Is it this one? Okay. All right, let's do this one, guys. Same thinking here. F and G are inverses. Okay. So then what you do is you write the formula. 1, if this is G prime, then this is 1 over what? F prime. Set yourself up. Okay. So if this is 1 over F prime, okay, Ryan, can you put that away? Then what you know is this right here is the x value of my G, right? It's the x value of my G. Well, then what goes in this parentheses then? The x value of your F. Everybody good with that? If this is the x value of your G, this is the x value of your F. Okay, now how do I find the x value of my F? Go into another part of your paper, do a little micrograph. Okay, this is the x value of my G. So I put a point on the G and put 5 there. That is my x value, 5 comma something. All right, what does that mean about the corresponding point on the F? It's something comma 5. Nice. All right, can you tell me what this x value of my F is right here? 4. Very good. So you're reading this right here. This is 4. That means this is 4. That means this is 4. Can you tell me what f prime of 4 is? 3. So the answer is not 3 though, guys. What is it? 1/3. All right, now we finished our notes, right? Okay, let's go look at your homework, guys. These are the solutions. All the odd solutions were online, so let me read to you the even solutions. Check your work as you're going. Number 4 is 1/8. Number 6 is -1 over 11. Number 8 is 12. Number 10 is 1/4. Number 6 is -1 over 11. And number 12 is 4/3. And number 13 is 1. Okay, does anybody need anything repeated? You're good? The odd answers are already online. Okay, guys, go ahead and take a look at what you guys are doing and see if you guys have any questions. On the other periods, I'm trying to think. A lot of people asked about number 10. I think it was 10. Number 10 and 6, I believe. I'm not sure, actually. You guys tell me what help you guys need.
You said 10 was 4.
What'd you say?
You just said, when you were reading out the answer, you said number 10 was 1/4.
Yeah, but people had trouble doing it. So yeah, if you couldn't get that, then let me know. Yeah, you guys want to see number 10? Okay. Okay, let's do it. So I have them written here somewhere. I just got to find it. Okay, here's number 10. All right, so you know the questions aren't all going to be easy, right? So, and especially if trig is involved. All right, so let's look at number 10. The main idea is always the same, but of course, the derivatives can get harder and the trig can get harder. All right, so if you look at this, f and f to -1 are inverses, right? F to -1, Ryan, if you don't remember, is actually the way you write inverse. Okay, f to -1 is inverse of f. Yes, okay, but I don't like to call it f and f to -1, so I just call this g. So I just change the name of it, okay? You don't have to change the name of it if you don't want to, but I just make all my f -1s equal to g so that I don't have to work with f to -1, okay? So this becomes, don't forget the...
Not 1 over g, or is it just g?
No, it's just g. Okay, it's just g. The 1 over g only comes in when you're writing the formula. Okay, So this is a given right here, g prime square root of 3. So this is not 1 over g. I just copy this. Okay, just like the other problems, I just copy this and I write the formula. What is the formula for g prime? 1 over f prime. Very good. Okay, so then I say, this was given to me. This is the x value of my g. In this parentheses, it's going to be the x value of my what? Of my f. Go to the side of your paper and do a little micrograph. Okay, do a little micrograph. Okay, what do I know? Of these 2 points, what do I know? The square root of 3. Now, what is that? That is the x value of my g. So let me put that in. That means g is square root of 3 comma something, which means I know the corresponding point for f. That would be something comma square root of 3. Okay, you guys good so far? So all the things we're doing, we're just repeating. Okay, now what we need to do is figure out what the x value of my f is. So if I come back up here, okay, I've got an equation for f. F of x is equal to tangent x. This square root of 3, guys, okay, and this is where students go wrong. Do I replace it into f of x or do I put it into x? Which one is square root of 3? Is it the x value of my f or is it the y value of my f? It's the y value, right? Because it's on the right side. So then you say square root of 3 is equal to tangent x. All right, let me rewrite this because this is... Make it a derivative. Not yet. Well, I'm trying to find the derivative, but before I find the derivative, I need to find this number here. Okay, so the first thing you do is find this number, then you do the derivative. Okay, so this number here is actually my x. Everybody good with that? If I can find this x value, that would be this number. Well, what number, if I take the tangent of it, I'll get square root of 3. And think about trig functions. This is actually an angle. If it sits next to the tan, sine, or cosine, it's actually an angle. So what angle, if you take the tangent value of it, are you going to get square root of 3? Go back to your unit circle. You guys need to memorize this. If ever the tangent value is square root of 3, you get a tall rectangle in here. Put in a tall rectangle, okay? And all of these points are actually square root of 3. It might be positive square root of 3. It might be negative square root of 3, but all of these are square root of 3s. If you ever have square root of 3 over 3, okay, those tangent values are like the short rectangle. Okay, so these points right here, okay, the short, I made it a little bit lower than I would want, but something like that. These angles here, these are your square, these tangent values are square root of 3 over 3. These tangent values are square root of 3. I just memorize it. The way I tell the difference though is because square root of 3 is tall, and if you divide by 3, you get short. Does that make sense? So that's how I remember it. So this is square root of 3. All these points are square root of 3. And so, guys, I want positive square root of 3 though. So if you think about tangent, which quadrant, let's see, think about the quadrants. Which quadrants will give me positive? Right? Which ones would be give me a tangent value of positive? This one for sure, right? And isn't tangent sine over cosine or y over x? Which other one would give me a positive number? Right? Because negative divided by negative would be positive. So these are my two quadrants. Okay, so the answer is either going to be this angle here or this angle here. All right. Look at what they tell you here. Which one do I have to pick? Yeah, the top one. Everybody good there? So the question is, what is this angle here? Maybe you could tell me in degrees. If I'm looking at that top one up here, it's I'm going higher than that. It's 60. I know I drew it look like 45, but it's a tall rectangle. So it's way up here. It's 60 degrees. What is that in radian land? Pi over 3. So this is actually pi over 3. All right. So this angle here is pi over 3, which means this x here is equal to pi over 3. This is the x value of my f. So this over here is pi over 3. This over here is pi over 3. And this over here is pi over 3. This is the x value of my f. I know it has a pi in it, okay? But you guys cannot be prejudiced against Greeks, okay? It has a pi in it, leave it alone. All right, so if I can just get the derivative of f and plug in pi over 3, I'll have my answer. So it's not as easy as it looks because guess what we have to take the derivative of? Tangent x. All right, let's do it. The derivative of tangent x is what? Secant squared x, all right? Now, I don't like this notation. This notation is very hard to understand. What you have to know is that secant x is really the quantity secant x, okay? And if you square it, the square goes on the outside like that. Okay, so this is really, f prime of x is really secant x times secant x. And the reason I'm spelling this all out is because now I have to replace x with pi over 3. So this means f prime of pi over 3 is equal to secant pi over 3 times secant pi over 3. Okay, take it one step at a time. How in the world can I figure out what secant pi over 3 is? That's not on the unit circle. What is secant related to? Secant is 1 over what? Cosine. Very good. Secant is 1 over cosine. Okay, that's a definition of secant. So this f prime pi over 3 is equal to, this right here is going to be 1 over cosine of pi over 3 times 1 over cosine pi over 3. You have to change it to cosine because nobody knows what secant of pi over 3 is. Okay, but you know secant is 1 over cosine. All right, now the question is, okay, let me go look at my unit circle. Pi over 3, you guys said was here at 60 degrees. Okay, what are my coordinates there at pi over 3? Isn't it 1/2 comma square root of 3 over 2? Okay, so what's cosine of pi over 3? The cosine value. Emily, you're with us? What's cosine value? 1/2, right? This is 1/2. This is 1/2. Guys, what's 1 divided by 1/2? 2. So this is 2 times 2. What's 2 times 2? Okay. Now my answer though is not 4. What is my answer? 1/4. Do you see why? Okay. The 4 is just this denominator here. All right. But your whole answer, you got to go back to the original formula, is 1 over this denominator, which is 4. What other questions do you guys have? Number 1? Oh, number 11. Okay. That's that little table right there? Okay. No, it's not the table. Okay, I didn't do number 11, so let me go ahead and copy it. Okay, so guys, we're looking at number 11. You want to know the derivative of the inverse of f. Okay, once again, the f and g are inverses. So instead of calling this f of -1, I'm going to call this g prime of 5. Don't forget the little derivative, okay? So on the side here, I'm going to say, I just called f of -1 equal to g. The reason is because I don't want to use f of -1. If you want to, then that's fine. And if you don't get it confused, that's fine. But like when you have to do -1 and then take a derivative, I kind of get all those exponents like all messed up. All right, so then what I do is I write what I'm trying to find. Okay, write your formula, guys. What's the formula? 1 over f prime, right? Okay, this right here is the x value of which function? G, right? Okay, I'm looking for the x value of which function? F. All right, go look on the side of your paper, draw a little micrograph, okay? I know the x value of my G, okay? But if I know the x value of my G, I also know the y value of my what? My F. Okay, so there it is. This is 5 comma something. This is something comma 5. Go back up to what they give you. What is this x value here if y is 5? 4. Okay, so I'm going to put 4 there, put 4 there, put 4 there. What's my f prime of 4? What's that? 2/3. So this is 1 over 2/3. Guys, what's 1 over 2/3? Flip it. What is it? 3/2. Is that right? Okay, so that is my answer. Be careful, guys. A lot of times when people flip it, they add a negative for some reason, or they take away the negative. The negative stays if it's there. It goes, you know, it doesn't, if it's not there, you don't add it. Okay, so this is just flipping it. All right, what other questions do you guys have? Number 9. Okay, guys, let's look at number 9. This is a good one. It's similar to number 10. Okay.
Oh, Miss Chang, I
Yeah.
heard you said we had a test on Thursday. Is that true?
It's next Wednesday. Are you going to be here? Oh, yeah. I don't know when their test is, but yours is on Wednesday. Okay. G prime of 1/2. Okay, that's what we're trying to find. F and G are inverses. Yes, they are. Okay, so this is a derivative of the inverse problem. Okay, go ahead, set it up. What's your answer going to be? If this is what you're trying to find, you copy it, and then what's your answer going to be? 1 over what? F prime. Okay. All right, so all you do is you write what you're trying to find, and then write the equation. All right, so this 1/2 is the x value of your G. All right, and so inside this parentheses is the x value of my what? F, okay. Draw a little micrograph over here, guys. F and G. What I know is the x value of my G. So do a little point, and that's going to be 1/2 comma something. Well, if this is 1/2 comma something, then this is something comma 1/2. Okay, those are called corresponding points. They always have them on inverse functions. All right. Now, the question is, can I find the x value of my f? If I know that y value of my f is 1/2, so here I am right here, that means 1/2 is equal to sine x. Can I find the x value? Think about your unit circle. At what angle? Remember, if x sits next to the trig function, if it sits next to sine or cosine or tangent, this is an angle. So I'm going to ask you, at what angle is my sine value 1/2? Think about it, guys. At what angle will I go up by 1/2? You guys see it? Here and where else? Here. Okay, what is this angle over here? Pi over 6. Okay, how did I get that? And why didn't I choose this one? Because right here it says just stay on the right side. It says from negative pi over 2 to pi over 2. So that's just the right side. All right. If I know my x value is pi over 6, then this is pi over 6, this is pi over 6, and this is pi over 6. Don't fret because there's a pi in it. Okay, it's okay. We're allowed to use Greek letters here. Okay. All right. Let's go ahead and figure out what f prime of pi over 6 is. I know what f is. F is sine x. How do I get f prime? What's the derivative of sine x, guys? Cosine x, all right? But I don't want f prime of x. I want f prime of what? Not 1/2. Oh, well, yeah, kind of.
Oh, well, pi over 6, right?
Yeah, cosine of pi over 6. Okay, now look at where pi over 6 is. What's the cosine value there?
Is it 1/2 or 3 over 2? I can't remember.
Well, it's the far one, right? Because it's the x value. So it's square root of 3 over 2. Okay, so this is going to be square root of 3 over 2. So guys, this is my derivative. So it's 1 divided by square root of 3 over 2. And so guys, we're going to flip it. So if you flip it, you get what? 2 over square root of 3. And if you wanted to rationalize it, if this were a free response question, you can leave it like this. If it were a multiple choice question, the answer might be rationalized. So what you need to do is multiply by square root of 3 over 3, and that would be the rationalized answer if it were multiple choice. Okay, what other questions are you having trouble with? Number 6. Okay, guys, let's look at number 6. Okay, so all the problems are the same. You can just see that sometimes the algebra is a little bit difficult or the derivative might be a little bit tricky. Okay, but all the problems are done the same way. All right, find the value of G prime if you know F and G are inverses. So make sure you understand though, F and G have to be inverses, okay? Find the value of G prime. So I'm gonna write down G prime of 2. Everybody good with that? Go ahead and write your formula, guys. G prime of 2 is equal to what? 1 over F prime of something. All right, this right here, this 2, this is always an x value. So it's an x value of my G. Okay, what is this missing parentheses right here? That is the x value of my F. Go to the side of your paper, put an F and a G, and go ahead and figure out which point you know. The only point I know here is the x value of my G. So I come up here, I put in a point, and that's 2. If this is 2 comma something, then guess what? This is something comma 2. Okay, now look, I'm looking for the x value of my f. I still don't have it because that would go in this blank right here. Okay, so let's go look at what I'm given. I'm given something comma 2. And so this is the y value of my f. Do you guys see that? Now be careful. The number one thing students do wrong is they stick the 2 right here. Is this the x value of my f? No, it's the y value. So you have to stick the 2 into the f of x. Okay, so you get 2 equals 3x to the 4th plus x. Now what you're gonna have to do is solve this. This is very difficult to solve actually. Factoring out the x isn't gonna work because you can't factor unless you have something that's equal to 0. So if I get this to be 0 and I try to factor, it's pretty much impossible for me. So what you're gonna have to do, okay, if you don't have a calculator, okay, and you won't have a calculator, what you have to do if you don't have a calculator is you do what you do on your test. What is it that you do on your test? You just guess, okay? You just guess. Try x equals 0, 1, -1. If it's a really hard problem, it might be 2 or -2. Okay, very rarely does it go to 3 or -3. So let's just try it. Try 0.
Why couldn't you just factor it and get the 2?
It won't work. Watch.
Okay, well, I believe you. You're good.
Oh, I can show you. I mean, this has to be a squared. Does that make sense for this to factor? A quadratic, yeah. So you can't factor it. But you could put it in your calculator. It probably would work, but you're not going to have a calculator. So let's go ahead and put in x equals 0. If this is 0 and this is 0, does that equal 2? Does that equal 2? No. Okay, let's not do x equals 0. Let's try x equals 1. Okay, if this is 1, so that's 1 raised to the 4th power plus 1. Okay, 1 raised to the 4th power is 1. So 1 times 3 is 3. Is 3 plus 1 equal to 2? No, actually, I think -1 will work. Try -1. X equals -1. Okay, that would be 3 times -1 raised to the 4th power plus -1. But adding -1 is really -1. Okay, guys, make sure you understand this. This is exponents before multiplication. Okay, so it's not 3 times 1 raised to the 4th. It's -1 to the 4th power. What's -1 times -1 times -1 times -1? If you do it 4 times, +1. So this is 3 times +1 minus 1. And again, it's multiplication before subtraction. So what's 3 times 1? 3, right? So 3 minus 1 is 2. So this works. So x equals -1 works. So that means that x is -1. The y of the g is -1, and finally this right here is -1, which is what we were trying to find in the first place. Now, what in the world is f prime? Can I find it? If I know f, can I find f prime? Yes, so f prime is equal to 12x cubed plus 1. F prime of -1 is equal to 12 times -1 cubed plus 1. Okay, you guys tell me what this answer is. This is -12 plus 1, which is -11. Be very careful. What a lot of students do wrong here is they multiply the 12 and the -1 together, and then they raise it to the 3rd power. And do you see that that's the wrong order of operations? Okay, so you need to do exponents before multiplication. This is -1. Okay, so what that means is this right here is not -1, -11. This right here is -11. So your answer, guys, is -1 over 11. Okay, Colton?
What were the answers to 12 and 13?
Was it like 3/2 and what'd you guys get?
4/3 and 1.
4/3 and 1, yeah, sorry. Okay, what other questions do you guys have?
What was the answer to
Number 4, did anybody get that? Answer number 4, guys?
1/8.
1/8. Did you get that?
No.
You want to do it?
Yeah.
Okay, we're looking at number 4, you said? Okay. Did you find your mistake?
Yeah.
Okay, then you're good. Okay, she's good. What other questions do you guys have? Okay, not bad, right, guys? But a little tricky, okay? And you have to know your derivatives pretty well. All right, can you guys at this time pull out your formula sheet? Leave your homework there. I'm going to check it. But pull out your formula sheet, and I want to do as many formulas as we can together. Yep, starting in the front. We're going to do a whole bunch of them. Ready? The first thing I asked, I think, is the 3 Pythagorean theorems. Okay, and let's go ahead and fill that out. This is what you're going to use for your final exam. And then you'll also see how much you've learned already, which is kind of impressive. All right. The cost of sin is $1. Okay, that is your Pythagorean identities. I think that's what we call them. Yes. Yes, go into the third tray right there by the pencil sharpener. Okay, the cost of sin is $1. And then do you guys remember this from pre-cal? I tan in a second. Make sure everything is squared. The 1 is also squared, but 1 squared is just 1, right? And then finally, I cut cheesecake. All right? Okay, so you need to know, you need to have these memorized for your test, but for your final exam, you can use your formula sheet. Okay? What is secant x? Secant x is really 1 over cosine x. You need to know that. Cosecant x is really 1 over sine x. Tangent x, do you remember that's really y over x, right? So that's really sine x over cosine x. And finally, cotangent x is just the flip of this. So that's cosine x over sine x. If secant x is 1 over cosine x, then cosine x is actually 1 over secant x. They're reciprocals of each other. And sine x is going to be 1 over cosecant x, if cosecant x is 1 over sine x. Tangent x, another one I want you to remember for tangent x is, oops, that's not right, is tangent x and cotangent x are reciprocals of each other. Okay, so another way to say tangent x besides sine x over cosine x is 1 over cosine x. And then another way to say cotangent x, guess what? 1 over tan x. Okay, I think you guys have the definition of a derivative down, right? Okay, and the alternate definition of a derivative we've done before too, I think. Let's look at the definition of continuity. This one is a function is continuous at C if, first of all, this must exist. Remember, the dot must exist, okay? But then also the limit as x goes to C of f of x, that must exist, okay? So what we're saying here is the limit must exist, okay? But for a function to be continuous, the dot must be in the limit. Does that make sense? So then we say f of C must be equal to the limit as x goes to C of f of x. Okay, I'm going to write this in red. On number 2, there's another way to write this, okay? And that is the limit coming from the left is equal to the limit coming from the right. Do you remember a long time ago we talked about when do you have a limit? You have a limit when you're coming from both sides. Do you remember that? And you get the same y value. So the red part right here, sometimes you'll see this instead of this blue, okay? But they mean exactly the same thing, all right? Let's do another one. Yeah, hold on. Average rate of change, guys, is just the slope. Okay. Which one do you need? The continuity one? Okay, definition of continuity. You're good, Colton? Okay. Emily, you're good? Okay. So guys, let's look at average rate of change. Average rate of change is y minus y over, wait, don't write that there yet, over x minus x. But guys, that's what you learned before you came to this class. When you came to this class, do you remember we learned this formula here? You've already tested on it. It's f of b minus f of a over b minus a. Really, it is y minus y over x minus x. Do you guys see that? It really is the same thing, okay? The intermediate value theorem says that if the function is continuous, then f attains every y value. So every value between f of a and f of b. These must be y values. The most common thing students do is they say x values here. They'll say a and b, which is not right. It must be f of a and f of b. All right. Right here, guys, the c, the derivative of c, the derivative of any number is what? 0. It's always 0. So that's going to be 0. What's the derivative of two numbers, or not two numbers, two expressions multiplied together? Product rule, very good. The derivative of the first times the second plus the derivative of the second times the first. What about this weird composite function thing? What rule is that? the derivative of f of g of x. Chain rule, right? It's the derivative of the outside, but leave the inside alone, leave it alone, times the derivative of the inside, okay? What's the derivative of sine u? Is it cosine u? Don't forget though, times du dx. It's not just cosine u, but it's cosine u times the derivative of your u. What's the derivative of tangent u? Secant squared u times du dx. And what's the derivative of secant u? Secant u times tangent u times du dx. Let me just say a caveat here. If I do any of these wrong, I'm sorry. You guys are still responsible for having the right one. You need to call me out on it, okay? Because I've been doing so many. All right, what's the derivative of x raised to the n? This is the power rule. Like if I had x squared, right? Wouldn't that be 2x to the 1? Okay, so this is going to be nx to the n minus 1. Does that make sense to you guys? Okay, this right here is the, what rule is that? Quotient rule. Okay, you guys know the quotient rule? Derivative of the first times the second minus derivative of the second times the first, all over what? All over the bottom squared. So the bottom here is g, so it would be g squared. Okay, I don't know how clear I am here. It doesn't look real clear to me from this side, so I'm going to try to fix this. Okay, that should be one dividing sign. All right, what about this cosine u? What's the derivative of cosine u? Negative sine u, but don't forget times du dx. Guys, do you see how none of these here start with a c? So you don't change the sign. But do you see how all of these start with a c? So this is going to be negative, negative, negative. Okay? And what's the derivative of cotangent? If the derivative of tangent is secant squared, then the derivative of cotangent is, guess what? Cosecant squared. Okay? If the derivative of cosecant is secant tangent, secant u tangent u, then the derivative of cosecant is going to be negative cosecant u cotangent u times du dx. You guys good there? Okay, so these are actually three things multiplied together. Even if, I guess if you count the negative, it'd be like four things multiplied together. You good? Okay, the derivative of ln of u, did you guys write that down already? Okay, what is it, guys? U prime over u. But guys, remember that u prime can bounce out, okay? So if it bounces out, you'll have a 1 on the top, and it bounces out to du dx. So make sure you have both of those just in case you need to use one or the other. This one students have a lot of trouble with, the log AU, but guys, it's just like this one, okay? It's u prime over u, except you have this extra thing. Do you remember what it is? Ln of a on the bottom, okay? And again, this top can bounce out, so if it bounces out, you end up with this 1 times du dx. All right, I think the derivative EU we've done, right? AU we've done. From here on down, we'll do this in a couple of days, I think. We're not going to do it right away, but we'll do it in a few days. So you don't know it yet. Move down to the mean value theorem, guys. Okay, with mean value theorem, do you remember what this is? If f is what? Continuous on the closed interval, and what on the open interval? Differentiable on the open interval. If f is continuous on the closed interval and differentiable on the open interval, then there exists a number such that, what is the mean value theorem? Remember, the derivative is equal to the slope, or the slope of the tangent line is equal to the slope of the secant line. Okay, and before this class, every time you talked about slope, you didn't specify, but you're always doing the slope of the secant line. Now that you're in calculus, you're doing the slope of the tangent line as well, which is the same thing as the derivative. Okay. All right, extreme value theorem says, this actually is what we learned. So we said that we could use the candidates test to find maximums and minimums. So this says if f is continuous, then you always have at least one absolute maximum and at least one absolute minimum. And since that is true, when you do the candidates test on a continuous function, you always have one maximum and one minimum. Okay, the definition of a critical number, guys, this says if f prime at some c is equal to 0, or if the derivative at some c is equal to d and e, those are where your critical numbers are. Remember how we would set f prime equal to 0 or d and e to find our critical numbers? That's what this is. Okay, that's good. All right, I think now you're moving to the top of the next page. And this one, I didn't really talk to you guys about. And this one just says, if you're actually increasing, then what happens is the y before is always smaller than the y after. That's all it's saying. If you've got all your y's, the y before is always smaller than the y after. If you're decreasing, then your y before is always bigger than your y after. Okay, and I just want to say, I don't think I'll ever test you on this because I don't actually know this myself. I had to look this one up. Okay. All right, I'm not even sure why I put this on. I don't think it's been on in the past. Okay, I do some crazy things whenever I'm putting stuff together for you guys. Okay, the first derivatives test, you know, I really don't like this format. I don't teach it to you guys this way, but let me just write it out so you guys can try to figure out what goes in the blank, because you could be asked what goes in the blank. So the first derivatives test is when f prime is positive, f is increasing. Do you remember this? And when f prime is negative, f is decreasing. And if you ever move from the top row to the bottom row, then you have what's called a relative max on f. And if you ever move from the bottom row to the top row, then you have what's called a relative min on f. Okay, so let's see what answer this is. This says when f prime changes from something to something, you have a relative min. So guys, what does f prime have to change from to have a relative min? Very good. So that's what you put in the blanks. All right. Then the next blank says if f prime changes from something to something, have a relative max. So which one is that? All right. Nice job. All right. The second derivatives test is kind of weird. We don't, well, I say we don't use it a lot. I use it a lot. I use it every year. But the second derivatives test is not as common for you guys because we don't do it a lot for you guys. But this says if you have a derivative of 0, okay, and the second derivative is, okay, now this one you want a relative min. So remember, you use what God gave you. Take your hand. I think the people online can't see me, but take your hand and make a relative min. So a relative min looks like this, right? This is a relative min because you guys see the minimum would be down here, okay? Is my second derivative, this is concave up, is my second derivative negative or positive? Concave up, positive, okay? So this is saying if your second derivative is positive, okay, or you can say greater than 0, means the same thing, then you have a relative min, all right? But if your first derivative is 0 and your second derivative is negative, okay, that means I'm concave down. Do you guys see that? If I'm concave down, then do you see you have a relative max? Do you see that on my hand? Okay, so that's a relative max if your second derivative is negative. And another way to say that is less than 0. Okay, let's keep moving. I think the next one is a concavity test. All right, guys, this is a long-winded way, okay, to say what I taught you. And so let's just make sure you remember what I taught you. When f double prime is positive, f prime is increasing and f is concave up. Super important to know this. When f double prime is negative, f prime is decreasing, f is concave down. I would recommend you write this down, even if it's not in the blanks, because this is way easier to understand than all these blanks, okay? These blanks is how most textbooks teach it and how most calculus teachers teach it, but I think this is way hard to understand. Just think about this picture. If you move from the top row to the bottom row, or the bottom row to the top row, what do you have? A point of inflection. All right, let's answer these questions now. Let f be differentiable. The graph of f is concave. What if something is increasing? Okay, so what has to be increasing if f is concave up? If f prime is increasing. So f prime is increasing if f is concave up. Sorry, I kind of gave away some of the answers. Okay, on the interval, and then if that's concave up, this must be concave down if what is decreasing? F prime. Do you guys see where I got that F prime? Okay, this right here is what you should memorize. All right, let's look at this one. If blank for all x, then the graph of f is concave up. This is concave up. What they're getting at here is if f double prime is positive. If f double prime is positive, f is concave up. If f double prime is negative, f is concave down. okay? A POI happens. Do you guys remember how we found possible POIs? We had to figure out if F double prime is equal to what? 0 or D and E. Okay, so this tells you if there's a possible POI, and you can confirm it if F prime changes from, oh, sorry, this is F double prime. If F double prime changes from what? Positive to negative or negative to positive, okay? I need to scroll this down, but I don't see oh, here's a scroll bar. Okay, and then finally, what would F prime change from to have a POI? What does F prime change from? Increasing to decreasing or decreasing to increasing. All right?
Wait 1 second.
Oh, okay.
Go down.
Oh, sorry. Okay, and then let's go to the very last things. Velocity, another name for velocity, if you take the position and you find the derivative of that. Okay, another name for speed is the absolute value of velocity. Another name for speed is if you take that velocity and you put in absolute value. Acceleration has a lot of names. It's the derivative of velocity, but it's also the second derivative of position. These two, I'm going to give you some better formulas in the future. The speed of the object is increasing when velocity and acceleration have the same signs, and guess what it's doing when velocity and acceleration have different signs? Decreasing, okay? And we are done. Look at all that you know. Look how many blanks you have filled in.